Hey there. You wanted to understand how electrons interact, and you sent in some really fascinating research to help us unpack this.
Cool.
There's this paper by physicist Dmitry Plotnikov
Right.
that starts with a quote that really caught my eye.
Oh, yeah.
It's from a book called Questions to God.
Okay.
And it talks about how contradictions actually drive knowledge.
Interesting.
I think that's super relevant here
I see.
because Plotnikov is basically saying our classical understanding of electron interaction, Coulomb's law,
Right.
runs into some major roadblocks when you bring in quantum mechanics.
What's fascinating about Plotnikov's work is that he highlights a fundamental contradiction
Okay.
at the heart of how we think about electrons. On one hand, we have Coulomb's law,
Right.
which tells us that opposite charges attract,
Yeah.
and the force depends on the amount of charge and the distance.
Yeah. That's pretty straightforward, right? Like magnets,
Yeah.
opposites attract.
Right. But then we zoom in to the quantum level, and things get really weird.
Oh.
One of the fundamental principles of quantum mechanics
Yeah.
is that only identical particles can interact. These particles are called coherent.
Okay.
Think of it like two singers hitting the same note
Right.
at the exact same frequency.
Gotcha.
They're in sync and can create a stronger,
Yeah.
unified sound.
Okay.
That's coherence.
I'm with you so far.
Okay.
But aren't electrons... Well, whole electrons,
Gotcha.
why wouldn't they be identical?
That's the catch.
What is it?
Each electron has unique properties,
Really?
like its energy level and spin. It's
Oh.
like each electron has its own little fingerprint.
Okay.
So in a closed system,
Yeah.
according to quantum mechanics, they shouldn't be able to interact at all
Whoa.
because they are incoherent.
Wait, so if electrons are never truly identical,
Right.
they shouldn't be attracting or repelling each other. But that's not what we see in the real world.
That's the mystery Plotnikov is trying to solve.
So what does he do?
His solution involves going beyond these classical models
Okay.
to show how this interaction can happen. He starts by analyzing a single electron in a closed system.
Hold on.
Okay.
How can one electron tell us anything about how they interact?
Yeah,
It's like trying to understand a conversation by listening to only one person talk.
you raise a good point.
Right.
It seems counterintuitive. But stick with me.
Okay.
Plotnikov's model describes this single electron as having two possible spin states, up and down.
Okay.
Imagine it like the electron is constantly flipping a coin,
Right.
heads for spin up, tails
Yeah.
for spin down.
Gotcha.
He visualizes these two possibilities as two virtual electrons.
Okay.
It's not that the electron is physically in two places at once.
Right.
It's more like it has the potential to be in either spin state.
Yeah.
And that's what influences how it interacts.
Okay, I'm picturing this electron flipping between two spin states.
Okay.
But where does the interaction part come in?
Here's where it gets really interesting.
Tell me.
Plotnikov introduces the concept of a point Q,
Point Q.
which is the midpoint between these two virtual electron positions.
Interesting.
At this point, Q,
Okay.
the combination of spins from the virtual electrons, creates two probable energy states.
So the electron is flipping between spins,
Right.
and this creates two different energy possibilities
Yeah.
at this midpoint.
Exactly.
Got it.
Okay.
What happens next?
Well, Plotnikov uses some seriously advanced math
Right.
involving things like Hamiltonians
boy.
and linear differential equations
Yeah, I'm going to need you to break that down for me.
to describe the energy levels at point Q.
You're losing me a little with the math.
Sure.
Can you bring it back down to earth for me?
Imagine a swing set.
Okay.
When the swing is at its highest point,
Uh-huh.
it has a lot of potential energy.
Right.
As it swings down, that potential energy is converted to kinetic energy,
Okay.
the energy of motion.
I'm following.
Similarly, point Q has different potential energies,
Got ya.
depending on which spin state the electron is in.
Makes sense.
The probability of point Q being in a specific energy state is described by what's called a potential function.
Okay.
And this function changes over time,
Oh, yeah.
just like the swing's potential energy changes as it swings back and forth.
Okay, now I'm seeing it.
Good.
So we've got this electron with two spin possibilities,
Right.
creating this midpoint with fluctuating energy.
Yeah.
But we're still talking about just one electron.
Right.
How does this model explain how two electrons interact,
Okay.
especially if they aren't supposed to because they are incoherent?
Now we get to the heart of Plotnikov's model.
Lay it on me.
When you introduce a second electron, also with its two virtual electrons and its own point Q,
Okay.
we start to see how interaction can happen.
All right.
Since the two electrons are incoherent, their points Q can't directly exchange energy.
So they're just kind of doing their own thing.
They are like two ships passing in the night.
I like that analogy.
Close, but unable to exchange cargo.
Right. We have our two incoherent electrons with their points Q, each doing their own thing.
Exactly.
But how do they influence each other if they can't directly exchange energy?
That's where things get really wild.
I'm intrigued.
Plotnikov points out that within this two-electron system, two additional points emerge, which he labels B1 and B2.
B1 and B2.
Each B point arises from a specific combination of virtual electrons.
Okay.
One from each of the original electrons.
So we're seeing these new points, B1 and B2, pop up as a result of the possible combinations of these virtual electrons.
Right.
Why are these points so important?
Because they provide a way for the electrons to interact indirectly.
Okay.
Remember how I said coherent particles can share energy?
Yeah, like singers in sync?
Exactly.
Right.
Well, the virtual electrons that make up the B points happen to be coherent with each other.
So while the original electrons are incoherent, these new B points are coherent and can exchange energy.
Yes.
Things are starting to click into place.
Sure.
And here's the kicker. Plotnikov demonstrates how the energy exchange between these B points leads to a constant attractive force between the two original electrons.
Exactly.
This is a completely different way of looking at the force between charged particles.
It is, isn't it?
Whoa, hold on. So you're saying that even though the electrons themselves can't interact directly, they create these middlemen, these B points that can interact, and that's what creates the attractive force.
Exactly.
That's mind-blowing.
It is a completely different way of thinking about it.
Wow. This is already so much more complex than I thought.
It is, and you said this is just the beginning.
Well, there's more.
What else does Plotnikov uncover with this model? Well, remember that quote about contradictions leading to knowledge?
Yeah. About how they drive knowledge?
Plotnikov's model doesn't stop there.
Really?
He actually uses it to explain something we usually just take for granted.
What's that?
The concept of spin.
Oh, wow.
But we'll dive into that after a quick break.
Can't wait.
Okay. Before we get to spin, there's one more piece of this puzzle we need to look at.
Okay.
Remember we talked about how the interaction between electrons is actually mediated by those B points?
Right, those coherent points that can exchange energy.
Well, Plotnikov discovered something really revolutionary about how that energy exchange works.
What's that?
He found that it's not uniform throughout space.
Non-uniform.
Yeah.
Okay, now you've really piqued my curiosity. What does that mean exactly?
Think of it like this.
Okay.
Imagine you have a magnet.
Got it.
You probably picture the magnetic field as these smooth, invisible lines of force flowing around it, right?
Yeah, that's the classic picture.
That's the classical picture. But Plotnikov is saying that at the quantum level, the interaction isn't so smooth and predictable.
Okay.
It's more like a landscape with peaks and valleys.
So instead of a constant force field, the interaction between electrons has hot spots, places where it's stronger and weaker.
Exactly.
Interesting.
And the crazy thing is...
What's that?
The strength of the interaction depends on where these probability amplitudes...
Probability amplitude.
Remember those potential functions?
Oh, yeah, like the swing set we talked about.
Exactly.
So
the more likely the electron is to be in a certain spin state at a particular location, the stronger the interaction will be at that point.
You got it.
Okay.
Plotnikov even derived an equation for what he calls elementary charge spin.
Elementary charge spin.
Which describes this non-uniform distribution of energy exchange.
Okay.
He actually visualized it.
How so?
Picture a topographical map with contour lines showing the varying strength of the interaction. I'm picturing it.
Some areas have high peaks, indicating strong interaction, while others have valleys where the interaction drops off to zero.
So we're basically throwing out the old textbook image of a smooth force field.
Pretty much.
And replacing it with something way more dynamic and unpredictable.
Yeah, much more nuanced.
Does this change how we think about the behavior of electrons?
It absolutely does.
How so?
It challenges the simplicity of the Coulomb model.
Okay.
Showing that the interaction between charged particles is far more nuanced than we previously thought.
So it kind of breaks that classic model.
In a way, it does.
That's pretty major.
It is a big deal.
And this could have massive implications for how we understand and manipulate electrons.
Absolutely.
In everything from electronics to material science.
Exactly.
This is giving me a whole new perspective on something I thought I understood.
Good.
So Plotnikov uncovered this non-uniform exchange.
Right.
What does he do with that information?
Well, this is where Plotnikov takes his model to a whole new level. He suggests that the same principles behind electron interaction could actually explain how atoms themselves are held together.
Hold on, are you serious?
Yeah.
It's a huge leap from 2 electrons in a box.
It is a big jump.
Are you telling me this model could explain how the building blocks of matter are formed?
That's exactly what he's proposing.
Wow.
Remember in the classical view,
yeah,
we just say the electron is attracted to the proton because opposite charges attract.
Right. Basic Coulombic attraction.
But Plotnikov suggests a much more intricate dance is going on.
Okay, I'm listening.
Just like with the 2 electrons, you can imagine the proton and electron each having their own set of virtual particles.
Right.
And those all-important B points that allow for interaction.
Okay.
Even though they're fundamentally different particles.
So instead of relying on this simple Coulombic attraction,
right,
we're looking at this dynamic exchange of energy between coherent points that arise from the wave nature of the particles.
That's the idea.
It's like a whole new language for understanding the forces that shape the universe.
It really is.
And it doesn't stop there.
Nope.
Plotnikov suggests that this model might even shed light on the strong nuclear force.
He does.
The strong force.
Yeah.
The one that holds the nucleus of an atom together.
That's the one.
He's really swinging for the fences here.
He is. And, it's this kind of bold thinking, challenging established ideas and looking for deeper connections.
Right.
That often leads to the most profound scientific breakthroughs.
Absolutely. This is incredible.
It is pretty amazing.
We've gone from electron interactions to potentially understanding the forces that hold atoms and even atomic nuclei together.
It's a lot to take in.
My mind is officially blown.
I can imagine.
But before we get too carried away, let's go back to that cliffhanger you left us with.
All right.
You mentioned that Plotnikov's model also explains spin.
I did.
Can you unpack that for us?
Sure.
How does this all connect?
Remember how we talked about those 2 additional B points that emerged when we added the second electron?
Right.
Well, to explain spin, Plotnikov expands his model even further.
Okay.
Bringing in 2 more B points.
2 more?
For a total of 4.
4 B points?
With these 4 B points, the system now has 2 distinct energy levels.
Okay, we have 4 of these coherent points, all capable of exchanging energy.
Right.
How does that lead to spin?
Well, here's where things get even more fascinating.
Yeah, let's hear it.
The energy transfer between these points isn't random. It has a specific direction. And that directional flow of energy is what creates the phenomenon we observe as spin.
So you're saying spin isn't just some inherent property of electrons.
Right there with that.
That it actually emerges from this complex interaction between different energy states.
Exactly.
That's pretty radical.
It is a different way of thinking about it.
It really is.
Yeah.
This is giving me a whole new level of appreciation for the complexity and elegance of the quantum world.
It is amazing, isn't it?
Everything is connected, and even the seemingly simplest concepts like spin have these hidden depths.
They really do.
It makes you wonder what other mysteries are out there just waiting to be unraveled.
It really does make you wonder.
Yeah.
It really makes you wonder what other mysteries are out there just waiting to be unraveled.
You know what strikes me most about all of this is that something as seemingly simple as the attraction between 2 electrons has taken us on this journey to the very foundation of matter itself.
It really has.
It really underscores just how much we still don't know about the universe.
And how much beauty there is in what we're discovering.
Right.
Plotnikov's model is a testament to the power of questioning assumptions.
Absolutely.
He didn't just accept Coulomb's law at face value.
Nope.
He dug deeper.
Yeah.
Looked for inconsistencies.
Right.
And ultimately proposed a completely new way of understanding how particles interact.
He essentially said, hold on, there's a whole other layer of complexity here that we're missing.
And that's the essence of scientific progress, isn't it?
I think so.
Pushing the boundaries of what we think we know and embracing new ideas, even if they seem radical at first.
Yeah, just think a few decades ago, concepts like virtual particles and non-uniform exchange would have sounded like science fiction.
Totally.
Now they're helping us unlock the secrets of the universe.
It's amazing how quickly things change.
It's mind-boggling to think about how these once abstract concepts are now shaping our understanding of the very forces that hold everything together.
They really are.
So for all of us out there who aren't physicists,
what's
the key takeaway from all of this?
That's a good question.
What does Plotnikov's work tell us about the nature of the universe and our place in it?
I think the biggest takeaway is the power of perspective. By shifting our viewpoint, by challenging the traditional models, we can gain a much deeper understanding of the world around us.
That makes sense.
Plotnikov's model is a perfect example. By looking at electron interactions through the lens of quantum mechanics, he revealed a hidden complexity that completely changes how we understand the forces that shape our reality.
It's like putting on a new pair of glasses and suddenly seeing the world in a whole new light.
Yeah, it really is.
And it makes you wonder what other breakthroughs are waiting just around the corner.
There's so much left to discover.
Maybe someday we'll be diving deep into a unified theory of everything.
Wow.
All thanks to insights sparked by models like Plotnikov's.
That would be incredible.
That would be a truly remarkable deep dive.
Yeah, it would.
Until then, the best we can do is keep our minds open to the possibilities and never stop exploring the mysteries of the universe.
Well said. I think that's a perfect note to end on.
And to all of you listening, keep those questions coming.
Yeah, keep them coming.
We'll keep diving deep, searching for answers.
We will.
And maybe even uncovering a few more mind-blowing surprises along the way.
You never know what we'll find.